When it comes to the competition between China and the United States, everyone focuses on microchips, artificial intelligence, space, and rockets. But perhaps this seemingly worthless sandy land is the main reason behind the rivalry between the two countries. What looks like sand is actually tiny particles of the most valuable metals, known collectively as rare earth elements. Rare earths have become an essential resource for modern society. They're found in our phones, speakers, hard drives, computers, electric vehicle batteries, wind turbines, and much more. But rare earth elements have also become a critical strategic resource for nations, because nearly all cutting-edge modern weaponry requires their use. Over 3,400 types of U.S. military equipment rely on rare earth materials. For example, the state-of-the-art American F-35 fighter jets each contain 417 kilograms of rare earths. Beyond the F-35, every Arleigh Burke-class destroyer requires 2,350 kilograms of rare earths. Virginia-class submarines need 4,170 kilograms. And other weaponry, from attack helicopters and anti-tank missiles to tomahawks, radars, night vision devices, sonar systems, and more. All the armaments that make the U.S. the world's leading military power depend almost entirely on rare earths. But today, global production capacity for these elements is almost completely monopolized by one country, China. Not only does China hold the world's largest reserves of rare earths, but it also produces 85 to 90% of the global supply of rare earth elements. China's monopoly in the global rare earth production chain is all-encompassing. From mining and separating elements to processing and manufacturing final products, China dominates the world market. For the U.S., the situation where nearly its entire defense system relies so heavily on its biggest competitor, a country that could now even be called hostile, has become an extremely serious problem. This topic is so sensitive that politicians in the U.S. and China rarely discuss it publicly or in detail. As a result, many people have only a superficial understanding of this issue, which concerns the future of the global order. Will the U.S. and its Western allies be able to catch up with China in rare earth production in the coming years and break free from their dependence on China for this critically important resource? To answer this question, we first need to understand the history and how it all began. How exactly did China become the global hegemon in the rare earth industry? The first country to start large-scale mining and use of rare earths was the United States. In 1949, American geologists in the Mojave Desert, about an hour south of Las Vegas, discovered rare earth elements. Back then, they were seen as little more than a geological curiosity. It wasn't until the 1960s that Americans realized one of the rare earth elements, called europium, could make the red color in television images brighter. That's how the rare earth industry was born.
CBS presents this program in color.
What are rare earth elements? They're a group of 17 different elements located at the bottom of the periodic table, with atomic numbers from 57 to 71. Their names, mostly derived from Greek, are quite complex, like lanthanum, neodymium, praseodymium, and so on. Some have luminescent properties. For instance, terbium can enhance optical signals in fiber optic cables, while gadolinium has magnetic properties and is widely used in MRI and CT machines. One of the most widely used rare earth elements is neodymium, which is used to create powerful magnets. For example, every electric vehicle needs 1 to 2 kilograms of neodymium for its motor, and the vibration function in our phones is also powered by neodymium magnets. It's worth noting that the name rare earth elements is a bit misleading. In reality, rare earths aren't all that rare. Global reserves of rare earths far exceed those of silver and are found almost everywhere. There are even rare earth elements in the soil in your backyard. However, in most places, their concentration is too low. Only in a few locations on the planet is the concentration high enough for profitable mining. While China has the world's richest rare earth resources, global reserves far exceed demand. For example, in 2024, global rare earth production was 390,000 tons, while known global reserves are around 120 million tons, enough to last over 300 years. Moreover, scientists reasonably believe there are still many undiscovered rare earth resources around the world. If that's the case, why has China become practically the only country dominating global production of these elements? The US has about 1.9 million tons of rare earth resources and began mining, processing, and using them back in the 1960s. At that time, China was in the midst of the Cultural Revolution, so how did it manage to make such a rapid leap and surpass the US? This is footage of a rare earth plant in Baotou, located in Inner Mongolia, China. These black dirty masses are toxic waste produced during rare earth processing. The wastewater generated in rare earth production eventually seeps into groundwater. Because of this, in some areas, the water becomes undrinkable and can harm human health. For example, wastewater containing fluorine can cause brittle bones, making people prone to fractures. Additionally, waste containing radioactive thorium is produced. This thorium can contaminate groundwater and spread over large distances. In dry weather, it can be carried by wind along with dust, spreading to cities and villages, causing radioactive pollution. The problem is that, while rare earths aren't rare and their extraction is straightforward, the process of separating rare earth metals from the soil generates large amounts of toxic substances. Worse still, it also produces significant volumes of radioactive wastewater. According to a 2021 Harvard University report, for every ton of rare earth metals produced, up to 75,000 liters of wastewater, dozens of kilograms of radioactive waste, and hundreds of kilograms of toxic byproducts are generated. The process also releases harmful gases, creating a heavy burden on the environment. In the US, where worker safety and environmental regulations are extremely strict, opening a rare earth processing plant is incredibly difficult. From the 1960s to the 1980s, the Molycorp plant in Mountain Pass, California, was the world's leading supplier of rare earths. However, in 1998, due to a pipeline leak that caused radioactive waste to seep into the environment, the plant was forced to shut down for nearly 20 years. Meanwhile, China was actively developing its rare earth mining and production, and in this imbalance, China quickly overtook the US and monopolized the global market. It's worth acknowledging that China was the first to recognize the enormous future potential of rare earths. Back in 1992, Deng Xiaoping said, "The Middle East has oil, and China has rare earths." At the time, Western countries didn't pay much attention to this. While American engineers were busy developing laptops, mobile phones, and other modern high-tech products, China quietly took control of the key raw materials needed to produce them. For example, one technology heavily reliant on rare earths is permanent magnets. Once magnetized, they retain their strength indefinitely and provide a powerful magnetic field in a minimal size. This is why our electronic devices have gotten smaller over the past 20 years. This technology was invented by Americans, but they didn't give it much importance and it was eventually bought by China. In 1995, China acquired the largest American rare earth magnet company, MagnaQuench, located in Indiana. China not only gained the patents and equipment, but also invited American employees to China to train local workers. Now, permanent magnet technology is widely used in modern weaponry and defense systems. In this chess game of rare earths, the Americans made a wrong move, while Deng Xiaoping made the right one. Of course, Deng Xiaoping's foresight about the potential of rare earths was crucial, but for China to monopolize global rare earth production in such a short time, another condition was necessary: ignoring environmental concerns. 10 to 20 years ago, China had virtually no environmental restrictions on rare earth mining and processing, nor did it enforce safety measures for miners. This was the fundamental reason China could rapidly develop its rare earth industry at extremely low costs. For example, the most notorious rare earth mine in China is the Bayan Obo mine in Baotou, Inner Mongolia. It's not only the world's largest rare earth mine, but also a storage site for 70,000 tons of radioactive thorium. All the rare earths processed here generate massive amounts of radioactive waste. Most concerning is the enormous tailings pond at Bayan Obo, designed to store toxic waste and radioactive wastewater. Rumor has it that this pond lacks effective containment, leading to constant seepage of radioactive substances into groundwater. 19 years ago, the Yangtze Evening Post reported that this radioactive wastewater was spreading toward the Yellow River, located 10 kilometers away, at a rate of 300 meters per year. Back then, media worldwide could still report the truth. However, all subsequent reports on this issue were removed. It's unclear whether the radioactive wastewater has reached the Yellow River, but the risks are clear. The Yellow River is China's second most important source of drinking and irrigation water. It's well known that miners worldwide work in environments harmful to their health. But in China, some claim that during the rapid development of recent decades, so-called cancer villages have emerged across the country. Due to severe environmental pollution from rare earth mining, cancer rates in villages near mines are significantly higher than the national average. Verifying this is extremely difficult, but the fact remains, the cost of producing rare earths in China is significantly lower than in Western countries. So when Chinese rare earths flooded the international market, their prices were so low that the few rare earth plants in the US and other countries simply couldn't compete and closed one by one. This gradually led to China's monopoly on the global market. Today, China holds a complete monopoly over the global rare earth production chain, from reserves to mining, processing, and manufacturing. Among explored rare earth deposits, China's reserves total 44 million tons, making it the leader and doubling Vietnam's reserves, which stand at 22 million tons in second place. Brazil follows with 21 million tons, Russia with 12 million tons, India with 6.9 million tons, and Australia with 4.1 million tons. The US ranks 7th with 1.5 million tons, less than 5% of China's reserves. However, at this stage, reserves aren't the most critical factor, as global demand is less than 400,000 tons per year, and it's assumed there are many undiscovered rare earth deposits. The main issue lies in mining and processing. This is where China's true hegemony in rare earths shines. In 2024, China accounted for 69% of global rare earth mining and about 90% of production. You might wonder why the numbers for mining and production differ, and why China's production volume far exceeds its mining volume. The thing is, mining involves extracting sand and soil containing rare earth elements. Production, on the other hand, is about extracting and separating rare earth elements from that sand. Mining is relatively simple, just digging and transporting. The real challenge lies in production. The fact that China accounts for 69% of global mining and 90% of production means other countries, after mining rare earths, send them to China for processing because only China has such a comprehensive and large-scale production chain. In 2024, the world produced about 390,000 tons of rare earths, of which China produced 270,000 tons, while the US, in second place, produced just 45,000 tons, or only 11%. From 2020 to 2023, 70% of the rare earths imported by the US came from China, 13% from Malaysia, and 6% from Japan. The US remains heavily dependent on imports from China. At this point, you might find it strange. How could the US allow such a critical resource, especially for its defense industry, to become so dependent on a country with a completely opposing ideology? However, in recent years, China's monopoly share has slightly decreased, as the West has finally recognized the seriousness of the issue. After about 15 years of anabiosis, the West has begun reducing its reliance on Chinese rare earths. The US, its Western allies, and Japan have started to realize that China's rare earth monopoly is a problem that can't be ignored. Surprisingly, this realization came thanks to a random event 15 years ago. This is footage from 2010 in the waters near the Diaoyu Islands, where a Chinese fishing vessel repeatedly collided with a Japanese Coast Guard patrol ship. Eventually, the Japanese arrested the Chinese vessel's captain. 2 weeks later, China took unexpected countermeasures that shocked everyone. It halted rare earth exports to Japan. This decision caused panic in Japanese industry, as Japan is a major electronics producer, and modern electronic devices can't function without rare earths. In 2010, China's rare earth monopoly was even stronger than it is now, controlling nearly 100% of global supplies. After the Diaoyu Islands incident, China cut rare earth exports by 72%, causing prices to skyrocket. Some elements became 5 times more expensive within months. The panic lasted over 6 months until China gradually resumed supplies. The public eventually forgot about the incident, but it served as a wake-up call for the West and Japan. They realized the need to develop their own rare earth industries to gradually reduce dependence on China. As a result, in 2017, the Mountain Pass rare earth mine in California, which had been closed for nearly 20 years, resumed operations. Australia, which previously didn't mine rare earths at all, began ramping up production after the Diaoyu Islands incident, from 0 in 2010 to about 20,000 tons per year by 2017. The US also went from no production to 45,000 tons last year, and that volume continues to grow. Additionally, US and Australian mining companies have started operating not only in their own countries. Due to strict environmental regulations and high labor costs, they've begun developing production in Southeast Asian countries like Malaysia, Thailand, and Myanmar. This chart clearly shows changes in global rare earth production over the past 30 years. The red color represents China's market share. We can see that from 2003 to 2012, China controlled nearly 100% of global rare earth production. However, after 2012, other countries began increasing their capacities and gradually taking market share from China. We can see that since 2017, their shares have noticeably grown. Looking back, in the eyes of the current Chinese government, the decision by then-President Hu Jintao to restrict rare earth exports to Japan was a premature move that revealed China's trump card too early. If China's rare earth monopoly today were as strong as it was in 2010, 100% of the market, it would have more confidence in trade war negotiations with the US and in plans for forceful reunification with Taiwan. Compared to that, the 2010 dispute with Japan was a minor issue. Revealing the ability to halt rare earth supplies gave the West time to wake up and prepare. But even after 15 years of preparation by the West, China's position in the rare earth production chain has only slightly weakened, and it still maintains absolute leadership, especially in processing and production. In 2024, China still held 85 to 90% of the global market. With the accelerating deterioration of China-US relations and the rise of global isolationism and protectionism started by Trump, will the US and the West be able to fully break free from dependence on Chinese rare earths in the coming years? Share your thoughts in the comments. According to forecasts by American experts, even with full government support, it will take at least 5 to 10 years for the US to achieve self-sufficiency in rare earths. That's in the best-case scenario, and in reality, it could take even longer. This is especially true for the 7 heavy rare earth elements, where China still holds a near 100% global monopoly, and they're irreplaceable. Chinese authorities are well aware of this. After Trump imposed 145% tariffs on China, China immediately announced export controls on 7 categories of heavy rare earths: samarium, gadolinium, terbium, dysprosium, lutetium, scandium, and yttrium. The fact that subsequent China-US negotiations concluded so quickly is likely directly tied to the US's vulnerable position due to its rare earth dependence. Many Americans and Trump supporters now pin their hopes on Ukraine. They say Trump's deal with Ukraine for mineral extraction in exchange for continued support is tied to interest in Ukrainian rare earths. But this is completely false information. All global geological reports, including American ones, don't confirm significant rare earth reserves in Ukraine. It's likely that Trump was misled by his advisors. In mid-2024, Republican Senator Lindsey Graham explained on CBS why the U.S. should continue supporting Ukraine against Russia.
They're sitting on $10 to $12 trillion of critical minerals in Ukraine. They could be the richest country in all of Europe.
Earlier this year, in an interview, he said again,
But you know the richest country in all of Europe for rare earth minerals is Ukraine? $2 to $7 trillion worth of minerals.
First, he mentioned $10 to $12 trillion.
$10 to $12 trillion.
And 6 months later, the figure suddenly dropped to $2 to $7 trillion. That's a huge difference. So this guy is basically just talking nonsense. In reality, Ukraine's rare earths aren't worth $12 trillion or even $1.2 trillion. Why? Because global rare earth reserves don't even come close to such amounts. Known global rare earth reserves are less than 100 million tons. At the current average market price of about $12,000 per ton, the total value of unmined rare earths worldwide is around $1.2 trillion. Could Ukraine's reserves exceed the global total? Moreover, even if such reserves existed, they couldn't be sold in such volumes. Current global demand for rare earths is less than $5 billion per year. $10 trillion is equivalent to global demand for rare earths over the next 2,000 years. So, this senator is just making things up. But even if we assume Ukraine has such reserves, it would take 10 to 20 years after the war ends to build the infrastructure for rare earth mining and processing. Such infrastructure already exists in the US and Australia. So, banking on mythical Ukrainian rare earth mines is completely unrealistic and unwise. Now you probably understand why the trade war between China and the US can't be long-term. Honestly, it's nearly impossible for the US to completely cut ties with China in the short term. Both sides are forced, however reluctantly, to maintain contact and take what they need. Now let's discuss who holds the better cards in this game. The US has a trump card in microchips, while China has rare earths. Whose card is stronger? Of course, the US has other trump cards besides chips, like advanced medicines, critical engineering software, even agricultural seeds, and so on. But if we compare just chips and rare earths, who has the greater advantage? In my view, the rare earth problem is much easier to solve than the chip problem. Chips aren't something you can just throw money at to fix. Producing advanced chips involves an extremely complex and interconnected system, from materials science and precision manufacturing to lithographic machines, EDA software, and decades of accumulated process optimization experience. Each stage requires the best experts and generations of engineering know-how. In contrast, rare earth mining and processing don't require highly advanced technology. Of course, over the years, China has obtained many patents in rare earth processing. But these aren't the most high-tech achievements, and they're not that hard to replicate. The main obstacles for the West in rare earth production are environmental regulations, compliance, and extremely high labor costs. But these are matters of trade-offs, not technology. In other words, in an extreme situation, like if China and the US completely cut ties or even go to war, environmental concerns and costs would take a back seat. In a state of war, the government would spare no expense and lift all restrictions to prioritize securing strategic materials. But in that same situation, modern chips are more like a work of art. They can't be created quickly, no matter the cost. So, overall, in this game, the US still has the greater advantage. Thanks for watching. If you enjoyed this video, give it a like, leave a comment, and don't forget to subscribe to the channel. Thanks again, everyone. See you next time.